Hi, in this chapter I shall attempt to describe batch process, mainly batch process and continuous process with reference to our controller UK-100 C-PGC. Now let us consider the types of processes. One is the batch process, other one is the continuous process. About continuous process, I shall devote one small chapter at the end of this series. For the present, let us take up batch process. The batch process has a finite duration. There is a start by command from an operator or maybe some automatic signaling, and there is an end, automatic end, except in the case of emergency there may be a manual end. The batch consists of a sequence of steps, and in each step set values are assigned to the variables like temperature, RH percentage, time duration, event release, which may include illumination and cooling utility, that's the compressor. This sequence or the combination of steps is called a program. That say the program consists of several steps, and in each step each variable in consideration has a set value. Okay, and this combination of steps called program is given a number. Such several programs can be set and stored in this controller, and each program can be assigned to a specific let's say application. Let's say program number 1 for damp heat test, program number 2 for dry test, program number 3 for accelerated let's say temperature and humidity cycling, program number 4 can be a plant growth type of cycle for 30 days. This way you can assign program number to each type of, you can say, recipe. Okay, now recall that type number, program number, and run. That way the batch is run. Okay, so it's as simple as that. So you don't have to every time think what is to be set and all. Once for all you set and keep calling the particular program numbers and running them. Now there are again a little different categories of these processes. One is ramp soak type of program, or you can say ramp dwell. Dwell or soak are same. I mean, or it's also called ISO type. So one is ramp soak type, the other one is only soak type. Now, excuse me, here I am showing you a ramp soak type of program. You can see the temperature rises to 50 degrees in a ramp fashion, soaks for 60 minutes, rises to 85 degrees, in 90 minutes soaks for 120 minutes, that's 2 hours, and comes down to 50 degrees in again half an hour. At the same time, the humidity also goes to say 95%, soaks, then comes to 50%, soaks, then go to 95%, and so the batch ends over here. It starts from here, it ends over here. In only temperature type of applications, generally it is a bit simpler. There is a ramp and soak for the temperature. But because here it is combined with humidity, it's a little more complex. In each step you have to set temperature value and humidity value. That is why we do not give rate. Rate becomes confusing because whether the rate is for temperature or for humidity. Instead of that, we assign the time. In this time, this temperature should reach here, humidity should reach here. The controller itself calculates the rate required and provides the traveling set points around which the control take place. So this is the ramp soak type of program. After the end of this, if there are number of repeats, the cycle repeats. Let's say the number of laps is set to 9. This type of program runs 9 times and then the batch ends. If it is set to 1, the batch ends here itself. Now this ramp and soak applications are generally for testing electronic modules, telecom equipments, automobile or even aviation instrumentation, or any moving parts checking, where gradual or even maybe sudden change of environment has to be tested, or the effect of that has to be tested. So that's it. I mean, here one more thing I would like to say. Supposing the temperature is going from here to here, it is not necessary, it tries of course to exactly reach here, but sometimes due to some reason the temperature suddenly say goes above this, let's say 85, even before this time is reached. Then the step has to change because there is no point in waiting for the traveling set point to reach. Or sometimes it may so happen that the temperature is not able to achieve due to some reason. Let's suppose the fuse has blown or something, then the heater doesn't work, then after restoration of that status, suppose it is able to reach, then only when it reaches the end point, the step changes. Only when it reaches the end point, the step changes. Otherwise, the ramp continues. Okay. So hence, the total time duration of this type of program is not 100% as per the calculation. Let's say it's 30 plus 60 plus 90, what is this? 90, 180, 300, 330 minutes. It is not necessary that this whole thing takes 330 minutes. It may be over in 310 minutes or it may be 345 minutes, depending on how the ramp shapes up. Okay. You can of course make it just end in a definite period, but then that is meaningless, because unless the end values are achieved, you should not proceed, or you should not wait after the end values are achieved. So this is one small point which I want to make. So this is a ramp soak method. Now we go to the next. This is only soak. Only soak. That means as soon as the step changes, the set points are attained. This humidity is 85%. As soon as the step starts, it is 85%. Here, as soon as step starts, it is 30 degrees. Of course, included illumination as a event like this. Now, suppose here the step changes and is 72%. The set value is immediately 72%. The actual value may reach after some time, but then the set value is immediately 72%. Here the set value is immediately 27. So each step is a soak step. Okay, here the total period is well defined. I mean, it is going to be within that much period, because irrespective of what happens to these values, the program continues as per the time schedule. Okay. Now the program starts as usual from here, when the program start command is given, and after this elapsed time, this step changes to second step, third step, and after third step the program ends. But the batch is not ending, because if the number of laps is 1, then the batch ends. Otherwise, it will execute that many number of laps and then end. Okay. So this is only soak type of program, elapsed time based. This type of program is suitable for plant growth or seed germinator type of applications. Okay. Now we saw this only one of the types, only soak type, elapsed time based. Now there is one more variation of this. This is also only soak type, type of program, but this is real time based. Here this timeline coincides with the time of the day, real time of the day, with the clock which is built into the controller. According to that it runs. Let's say here we can see this 00 is the 00 actual 00 of the day, that is the midnight. Here the first step starts, 20 degrees, no illumination, humidity is 85%. At about 9 o'clock, not about, exactly at 9 o'clock, the temperature set value goes to 30 degrees. Humidity also can change, I have not shown here, okay, that has remained. Now illumination comes to 75%, and then at 8 o'clock in the evening, the temperature again goes to 20 degrees and illumination goes to 0. RH, of course, I told you, I have just kept it as it is. It can also change. So here, say from 00 hours to 9 o'clock in the morning to 8 o'clock and then midnight, this is the sequence. And after the day ends, new day starts, new lap starts. Okay, so at any given time, if you see this, you can say, depending on the time of the day, you can say what should be the temperature and RH in this. Or alternatively, let us say the controller is not running the program, it is off, means it is, the batch has ended, earlier batch has ended. Now if you start the program say at let's say 1 o'clock, it will not start from step number 1, because this is step number 2. 1 o'clock falls in this. So it starts with step number 2, and then of course this whole sequence follows. Whereas in case of elapsed time based program controller, it always starts from step 1. Whenever you start, it starts from step 1. But here it depends. Suppose you start at here, let's say at 9 o'clock, it starts from step 3. Okay, so that is one difference I can say. So this is the type of this one. These are the types of program batches, and how do we set these programs, how to decide, or which factor decides what is running now, whether it is running on rampant soak or whether it is running on elapsed time soak or real time soak. That has to be also somewhere, somebody has to decide it. How is it decided? Which parameter is having that information? All those things we'll see in the next chapter. For the present, bye.